Hi, my name is Vladimir Vinogradsky, and I'm a program manager on App Service in Azure. I work on App Service API-related capabilities. And in the next 25 minutes, I will show you how API-related platform pieces fit together. I will try to position API management and explain its value to developers. And then I will spend the bulk of my time demonstrating how API management nicely works with API apps and functions. Customers are increasingly looking to the cloud for solutions for their key business scenarios, such as e-commerce, employee productivity, consumer engagement, and API publishing. Most of the technical solutions to these needs come in the form of apps, web apps, mobile apps, or APIs. Azure App Service is a high productivity, high control, fully managed platform optimized for building and hosting apps. It is aimed at startups and enterprises alike and offers a breadth of features, worldwide presence, high scale, enterprise security, and on-prem connectivity. In this talk, we're going to closely look at the API publishing scenario. APIs are being used to integrate disparate systems, monetize existing data and services, and open new channels to new customers. However, opening APIs to partners and internal and external developers is not without challenges. Creating consistent modern API facades over existing backend services, protecting them from misuse and overuse, getting insights into API usage and health are just a few examples of that. Meet API management. Azure API Management is a service that was purposefully built to help customers with challenges that come with publishing APIs. Here, I classified API management capabilities in 4 buckets. First one is facade. Essentially, API management allows you to decouple your API consumers from the implementation of your APIs or backend services. So it comes in many forms. First of all, you are exposing all your APIs behind one single URL and IP address, irrespective of where your backend services are located. You can hide certain part of functionality that is not appropriate for exposing as an API, but is available on your backend service. You can optimize your backend services for specific consumer channels by trimming down the information that is passing through. Second set of capabilities I named middleware. So these deal with cross-cutting concerns that are common to all APIs, such as security, caching, and logging. So API management has a lot of capabilities that can help you secure, protect your API, cache responses, enable request and response tracing, and essentially allow you to centralize and externalize these things out of your backends and into API management. Monitoring is the third bucket. Having insights into usage and health of your APIs is important. An APIM captures metrics and provides key reports out of the box. For those customers who are looking to monetize their APIs by selling them, we offer via our API the data that is necessary for them to create flexible business models. And lastly, developer experience. With API Management Developer Portal, you can treat internal and external developers the same way and provide them with a first-class experience. Developer Portal is out of the box, turnkey, and it comes with API catalog, API documentation, samples, and interactive console that enables developers to interact with your API without writing a line of code. So you can use API management with web apps, mobile apps, API apps, and function apps that were announced at today's keynote running on App Service. But you can also bring your on-prem APIs, third-party APIs your organization depends on, as well as expose Azure APIs in a simplified way, such as blobs, storage, queues, event hubs, and such. So let's look at what the architecture of API management. API management has three key components. Publisher portal, that is a browser-based portal that is interface that is used by API publishers, people who own APIs, who publish APIs, to manage them. This is where you can register API with API management, assign policies to it, look at analytics, and do other management operations. Of course, we expose a full management API so that management operations can be automated. Second component is developer portal, and I already mentioned that it is basically a public face for your APIs to your API consumers. It shows documentation, allows self-service onboarding, key management, and other sort of common developer concerns. And lastly, gateway. That is the key component, and it basically mediates all the requests to the APIs that are registered with API management, collects metrics and applies policies, protects your API, logs those requests, and does all the operations that you specify. Gateway connect to your backends using either directly over the public internet or via VPN. We support both basic and mutual security authentication, so we have a lot of flexibility in that way. And as I already mentioned, these APIs can be hosted pretty much anywhere and developed using any technology stack. Now, let's go and look at API management in practice and see how nicely it works with API apps and functions. I will do this demo in the context of the conference API. That is basically a demo API developed by Daryl Miller, and it's available on Git freely, so you can go and download it. And this API, we're going to see how we can sort of manage this API with API management and demonstrate the app service and API management in the context of it. So without further ado, let's go and do it. Here I have this conference API cloned to my desktop, and I open solution in Visual Studio. As you can see that this API is implemented using ASP.NET Web API framework, and it was created using API app template, which essentially is equivalent to Web API template with the addition of a package called Swashbuckle. That's basically an open source package created by Richard Morris, and it simplifies consumption of your APIs by generating its description dynamically. And this description is rendered in a format called Swagger, which is also open source. And it essentially, think of it as, for those of you familiar with SOAP, for instance, like WSDL for HTTP-based RESTful APIs. There's one other thing that Swashbuckle has inside it is Swagger UI, which is, again, another package provided by SmartBear, which essentially provides an interactive playground documentation for your API that is generated sort of dynamically, again, based on the Swagger generated by Swashbuckle. So with those two things, I'll show you how that simplifies the consumption and interaction with your API. So let's go look at the Web API. You see our controllers. You can see that we have basically controllers corresponding to resources that are normally associated with conferences, such as sessions, speakers, and topics, and days. And if we look at our sessions controller, for example, we can see that for session controller, there are methods to retrieve the full list, to retrieve a list of sessions by speaker name, by day, and by keyword. So it's fairly straightforward API. So now let's go and run it locally. So I'm pressing run button. The API has started locally. You see sort of I hit the root of that API and it generated this what we call JSON home document. And essentially what it does, it describes all the resources exposed by this particular API. So if we go and add Swagger to it, then we'll see Swagger UI, again, dynamically rendered based on Swagger. Description of this API, and you can see that we have all these resources such as these sessions, speakers, and if we can, if we click on sessions resource, we can see that we can issue a GET request to it. So let's try it, and we see a response. So it's a very nice way to quickly interact with your API. So this URL here points to actually endpoint on this API that generates Swagger description. So if we go to that and do GET on that, you can see that you get a Swagger description, you can easily search on the web and familiarize yourself with this format, but you can see that it basically, again, describes all the resources and methods and parameters exposed by this API. So very good. Let's go back here. Stop this. So we have pretty good tooling around APIs. So for example, right here from Visual Studio, you can publish this API into app service. I already have, to save some time, so you can see that I already have APIM conf API already published into app service, into one of my subscriptions. You can also see that API running in Azure on app service right here in API Apps Collection in Cloud Explorer. And what's more, you can see that I can actually do basic management operations for it. So it's a great work by our Web and Azure Tools teams. So let's go and see at this API deployed and running on app service. So let's click on this. Here we go. So as you can see that we have it deployed in Azure App Service. So there's a basic operation that you can do, restart, delete, get publishing profile, and things like that. You can also see that all capabilities of app service are applicable here, and they are really applicable to every kind of app that can be hosted on app service. And there are a few here that are related sort of more tightly to APIs. One is API definition, and here you can see that it just points to a Swagger endpoint on the API, so that you can use it to get the Swagger if you want to consume it. And then CORS, which stands for Cross-Origin Resource Sharing, which is a specification that prescribes how to enable access to APIs from domains other than the domain of the API itself. And here, as you can see, we have star as a setting, which basically means that we allow access to this API from browser-based applications from anywhere, from any domain. So a few other things to note here. You can see that this is a URL this API currently exposed under. So it's an Azure Web Sites URL. So I didn't assign custom domain name for this API. So let's go and browse to that API, and obviously we see the same JSON home document we saw locally. Also, if we go back and copy this URL, right, we can see that the API running on app service generates Swagger as well. So all this functionality is intact. So now, after we sort of looked at that and looked at how this API can be easily deployed on app service, we can go and see what we can do with it with API management. So let's switch to API management. API management, the bulk of API management functionality right now resides in a sort of special portal, which sits outside of standard Azure Management Portal. And here it is. So you can see the conference API there. You can see some stats about its usage, and you can see that I practiced a bunch of times before this session to just make sure that everything works. Obviously, you start with adding an API or registering an API with API management. You can do it either manually or in the case of API app where you have a specification of that API in Swagger, you can just simply import it. And this is what I did. Essentially, just copy this URL here, and easily import, quickly and easily import API into API management. So let's go and see if we can actually interact with this API right here in API management. So I'm going to open Developer Portal. in a separate window here in separate tab. Here are all the APIs, and right now I have just one conference API. So let's go and click on that. You see all the operations that are exposed by this API. We're going to just use the same get sessions operation that we tried locally. So let's go and click on that. Send request to this API and see what comes back. So we see a response here. So a few things to note. First of all, that the API now is available through API management, right? So whoever consumes this API through API management will be using this URL, not the URL of the API app itself. Second thing, we can see that in the response here we have a few headers that disclose technology stack it runs on. So we probably would want to remove those. As you can see here, this API is using hypermedia techniques, and it has URLs in the response that actually point back to the original API location on app service. So if this API is called through API management, we clearly want to change these URLs to point back to API management, of course, right? So there's a few things we have to do here. But other than that, we can perfectly interact with this API just by importing it into API management. So let's go and try to make the changes I described. So the power of API management comes from policies. Policies are essentially common API management capabilities that are encapsulated, as policies, and they can be applied in the inbound or outbound direction. So in our case, I'm going to just, to speed it up, I'm going to just copy a set of policies into this policy editor. So let me click configure, go full screen so we can see better. Select and copy and paste. So let's look at what we're doing here. So in the inbound, when request is coming from the API consumer into API management, and then before it's being forwarded to the backend, to the API app, we do the following few things. First of all, we remember sort of the time. We take a timestamp so that we can add an elapsed time to the response. Second policy here, again, sits in the inbound direction, is rate limiting. Without that policy, anybody can call this API at any call rate. It's probably not a good idea, so you probably want to sort of throttle back individual callers to some reasonable amount. And here I chose 3 calls per 10 seconds based on IP address. So each distinct IP address can make 3 calls over a period of 10 seconds. In the outbound direction, I'm applying find and replace policy to change the URLs from pointing to the API app, right, and make them point to API management instance instead of that. And that way, even though the API app is not does not know that it actually being sort of has this reverse proxy or API management gateway in front of it, we are sort of taking care of that. We don't require any code modification on the part of the API itself. Then we're removing a bunch of headers that are either outdated or disclose the technology stack information that we use to implement the API. And lastly, we are adding a header called time elapsed, where we simply adding the time that we spend processing this request in API management and API app. And note here that these expressions here, we call them actually policy expressions. They use familiar Razor syntax. They're just C# expressions. We have ability to use a broad set of .NET framework types in those expressions, and we can support sort of single line and code block expressions as well. So after adding these policies, let's save them. And let's go back and see what effect they have. So here I'm back in the developer portal. Let me send another request and see what comes back. So first of all, we see that there is time-elapse header edit, right? And now we see that the whole request here was processed in 175 milliseconds, which is actually less than response latency registered on the client, but that's understandable because this particular figure does not include the round trip from the client to API management and back. So we see that Pragma and X headers are removed as we hope they will be. And here we have references pointing back to API management instead of API app. So we basically achieved all of the desired effects, except rate limiting, right? Let's see if rate limiting works. So let's call this function one more time, 2 times, 3 times, and now we're calling fourth time, and we are getting throttle back, 429. Let's keep calling. In 1 second, we should be able to call again, and we do. So now we are applied rate limiting as well. So we made all these modifications really quickly by just creating a few policies in API management without touching any code or redeploying API app. So that's great. Now let's do something even more interesting. So imagine that we decided that we want to add ability to manipulate ratings for sessions to this API. And we tasked a different team with implementation of that functionality. Well, that team was very interested and excited about microservices architecture, and they decided to go and implement that functionality as a microservice, which is different, and distinct from our API app. And for implementation of that microservice, they chosen a new cool functionality from App Service called Azure Functions. So here's what they delivered. They created this Azure function over here. As you can see, they wrote it in C#, and this is a pretty basic function. This particular one just gets the rating, retrieves the rating. And as you can see, all it does is essentially connects to the database and fetches some information from the database. You can see that this function actually is triggered by HTTP request, and then it returns an HTTP response. This is a function URL, right? This is URL that is that you send requests to trigger execution of the function. And notice this code query parameter. This is essentially a secret key allowing you to access the function. So let's clear the logs. And now try to add this function to the conference API facade that we created in API management. So to do that, I am going to use a very neat feature that we recently released in API management, namely ability for you to manage API management configuration through Git with standard Git tools. Here I have Visual Studio Code with opened with a copy of recent clone of API management repository for this build demo tenant I was showing you. This basically reflects full configuration of the tenant, and now I'm going to go and change that configuration to mix in this function into the API. So here's configuration file for the conference API. So let's go to operations and add one. I have a little snippet here to speed things up. So as you can see, I'm adding get session rating by session ID function. Here's the relative path that's going to be used to invoke it. Note that the method is, HTTP method is get, right? And see that the name and the URL template or the path fits very well with the sort of conventions and structure of the existing API. So that's great, go save it. So now I want to do one more thing here. So in the inbound section of the policy applied to this particular operation, I'm going to add a few policies here. First of all, I'll change the method, HTTP method, to post, because that's what function expects. Also, I will change the backend URL to point to the function, not the API, as the rest of the operations on this API do. And then lastly, I'm going to rewrite the URL so that it actually takes a query parameter that it passes on to the function for session ID number, because remember, it's get ratings by session ID. And also note that I'm here including the code, access code for the function, and therefore hiding it from the consumer of the API. So after doing this, let's save. And let's go and commit those changes. So let's go back here and basically write a commit message saying edit ratings function. So I committed changes locally into my repository on my computer, and now I want to push those changes to the build demo tenant that I'm using for this demonstration. So let me just push those changes back. It looks like it worked. So the changes now are synced to the tenant repository. So at this point, I'm going to go back to API management and apply those changes. So let me exit here, go to the configuration repository, and essentially deploy this last configuration that I just pushed into this tenant. Deploy it, make it effective essentially. There we are, and it's green. So awesome. So it deployed well. So now let's go and try to exercise this new functionality that we just added. So let me refresh this page. And as you can see, first of all, there's a new operation here, get session rating by session ID. So let's go click on that. So it requires you to supply the session ID number, but I happen to know that there is a session ID number 1001. So let's go and invoke it. Here we are. So as you can see, we got a rating retrieved from a function, 88 for this session number 1001. You see that we still have time elapsed. We don't have technology stack revealing headers. So let's see if call rate limit still applies. So let's call it one more time, one more time, one more time, and one more time, and one more time. And here we see that, again, rate limit has applied. So now think about it. We have a public API facade for this conference API, which completely hides its implementation. So some of these resources are implemented by API app. Some of these resources are implemented by a function. We have common set of policies across those. And that's the value, just a quick example of the value that API management can provide by decoupling, essentially, API consumption and presentation from API implementation. All right, so we see that all policies apply to this operation as well. So let's go back to the function and see the logs. So as you can see, there is information in the logs indicating that the function was indeed executed. So we were actually sending requests to this particular function for the get ratings for session by session ID resource. So there was no tricks here. Everything is working like it should. So that's it for the demo. Let's go back to the slides. And now, after you've seen the demo, I hope you will go and learn more about API management, API apps and functions, and app service using the links provided on the slide. And we'll take some time to catch up on other app service talks. Thank you very much for watching, and have a great day.